Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. Today, I'm talking with Hannah Kerner about fields of the world and about a question that sounds trivial right up until you try to answer it. Where does one field end and the next one begin? Fields of the world started as a benchmark dataset built from ground truth boundaries across 24 or so countries, paired with Sentinel-2 imagery from planting and harvest. It's now the first open global field boundary layer, and it ships with a confidence layer, so you can see where the model thinks it's wrong. But before we get into this, I want to say a quick thank you to the people making this episode possible. The Cloud Native Geospatial Forum. The CNG Forum 2026 runs October 6th to the 9th at Snowbird, Utah. It's 3 days of real-world cloud-native geospatial, Stack, Cogs, GeoParquet, SAR, and more importantly, the teams who are actually developing these things at scale. It's not just theoretical, it's what's actually working. And if you want to get your hands dirty, there's a hands-on workshop day on the 6th. You can register over at 2026.cloudnativegeo.org. And of course, you'll find a link to that in the show notes of this episode. Hi, Anna. Welcome to the podcast. Thank you very much for taking the time to join me today. I really appreciate it. And for the listeners, I'm laughing a little bit because there's been a little bit of a flap here getting this all organized, but we're here now. And I'm really pleased to have you here in the studio. And of course, when I say studio, I mean my spare bedroom. So Hannah, you are the assistant professor at Arizona State University, the AI lead for NASA Harvest, and a research advisor for Taylor Geospatial. Welcome to the show. What does it mean to be the AI lead for NASA Harvest?
Yeah, thank you for having me on the show. So NASA Harvest is NASA's applied sciences program or Earth Action program on agriculture and food security. So the whole program works to advance the use of satellite data for agricultural applications and decision-making around the world. It also has a sister program called NASA Acres that is similar but focuses on only the United States. I'm also the AI lead for that program. And what it means to be the AI lead for both of these programs is that I kind of come up with and lead and advance different ways that we can move the entire field forward in terms of developing AI capabilities that are helpful for agricultural decision making.
My guess is that has a lot to do with Earth observation. Is that correct?
Yes. It has everything to do with Earth observations, and in particular, satellite Earth observations.
One of the projects I'm particularly interested in and I want to focus on today is fields of the world. But before we get there, I think probably a lot of people understand what it means to be an assistant professor. This research advisor for Taylor Geospatial, what does that role involve?
Yeah, so as the research advisor for Taylor Geospatial, I work with the team there to help identify what the most high impact research directions might be and where the organization might focus its efforts in terms of developing public good technologies that will advance the state of geospatial AI.
So that sounds like a sort of broader mandate than agriculture. Is that correct?
Yes, it is broader than agriculture. Agriculture is one of the core focus areas of Taylor Geospatial, but it is much broader in terms of really the entire field of geospatial AI.
And one more question before we move on to fields of the world. How did you get involved in all this? How did you become this expert in agriculture and remote sensing?
I think really just by following what seems interesting and where I can make an impact. I started in computer science because I felt like this was a really incredible area where you can do so much with so little. By typing on my computer, I can create things out of nothing that can impact people's lives globally, right? And so, that kind of intuition or interest led to another. And that's where I found myself working with NASA Harvest, NASA Acres, all these different groups in agriculture and AI and Taylor Geospatial, using satellite data in general. Again, I think is just such an untapped, underutilized resource that we have for so many different application areas. But also, I think I've really just followed the people, working with people who are fun to work with, have similar energy and goals, and really just want to get things done rather than talk about it. I think those groups are very well known for getting awesome things done.
Yeah, absolutely. There's something about being around inspired and inspirational people. I think it's amazing. Do you still have a sense of wonder when you look at satellite data in particular?
Oh, for sure. Sometimes I get lost, we'll be looking at one thing and then I look over in a side and I'm like, what is going on here? And then 10 minutes later, I'm like, what am I doing? What were we talking about?
Yeah, good. I'm glad there's someone else out there like that too, because oftentimes people talk about it as this wonderful resource and this data to be mined and exploited and do great things with. But for me, oftentimes when I'm looking at it, I'm like, it's just incredible. This image was taken from outer space.
Totally. And, with the frequency that we have these observations, I think a lot of people don't realize, like, you can see not just that outer space image of where you are, but you can see it yesterday, a few days before, a few decades before. It's amazing.
Yeah, it's absolutely incredible. Right. But enough sort of wandering around in the introduction. Fields of the World. Could you introduce that project to us, please?
Yeah, so Fields of the World started really as a benchmark data set, initially with Tailored Geospatial back a few years ago when it was called Tailored Geospatial Engine, or TGE, before the organization recently kind of was born anew as Tailored Geospatial. Several years ago, Jen Marcus, who's was the executive director of TGE, wanted to pick up essentially a first project that would exemplify this innovation bridge program that they had developed, where basically they wanted to show how you could move technology from a research setting to commercial settings in a faster way and be able to develop these research technologies together with academic researchers and like excellent engineers in the geospatial world, and be able to show how you can more quickly bridge that gap between research and deployment and commercial benefit. And so when we started talking about this program, we thought there's so many different things out there that you could look at in terms of technologies needed to create like public resources for geospatial AI. But in agriculture, which I also had a lot of experience with through the NASA Harvest and other related programs, one of the like key missing ingredients was field boundaries. And it really felt like this thing where it's not that it's just like a fundamentally hard problem. Like it's not like we're trying to figure out, how do we move like an untractable amount of mass from the Earth's surface to Mars or something, like it's not like we had to do something totally crazy to solve this problem. It's just that nobody had really done it and nobody had gathered the resources and the ecosystem or data needed to do it. And what we thought was that if we were to focus on that problem, we could demonstrate this pipeline of how you can solve a problem that's important to a lot of people by creating new data resources and new model resources and get those in the hands of users very quickly and have a, very quick feedback cycle between the academics and the users to be able to shrink that gap again between like research and commercial use or just public use more quickly. We decided to go after field boundaries as this kind of not so much low-hanging fruit, but solvable fruit that just so many people needed. Like we've been hearing about it for years and years. Oh, if we only had field boundaries, but all of the efforts have been fragmented. So we decided to tackle that first.
You just took the next question out of my mouth. If we only had field boundaries, we could do what? What could we do? Explain to us why these are fundamental to have a polygon delineating a field.
So essentially, if you don't have a polygon, you have pixels. And so what we had before field boundaries or without field boundaries is lots of like land cover maps, cropland maps, et cetera, that are all at the pixel level. So if you want to get insights that are at the field scale, like what is the yield in a particular field? When might fields be harvested? What are people growing? How many fields have been created in the last couple of years because of deforestation? All of these questions, almost everything that people want to know about agriculture boils down to thinking about field units. However, what we have are pixels from satellite data and then the derived products that we make with various models from the satellite data.
And I'm going to open a can of worms here. What's the hard bit about creating polygons, field polygons from pixels?
Yeah, so people think like, oh, this must be so simple until you show somebody a satellite image and you say, okay, draw the boundary. And then it becomes really hard because you think like, what's the hard thing? Especially in the United States or like countries where we have really large scale agriculture and, we might be thinking about just like these big rectangles in the US Midwest or something. Even then, it's not so easy actually. But, there are all kinds of questions like, oh, where exactly is the boundary? If you're trying to draw a line, is the line like in the middle of where it goes from like road to grass? It's never actually that clear, especially in relatively coarse satellite pixels. But another challenge is that over a growing season, what appears to be the boundary can change. So, if you look at the satellite image of one date versus another, the shape of that field might look different depending on, where it was in terms of its management life cycle. There are a lot of parcels that might look like fields, and in some places, the boundary between fields, especially when it's not mechanized agriculture, can be really hard to identify. So, there's an incredibly huge range of the appearance of fields over the world, but even within countries. This is where I get lost in the satellite images sometimes because, I'll be somewhere like in South America looking at one field and then I'm like, oh my gosh, like, can you believe like these are the tiniest fields I've ever seen right next to the hugest fields I've ever seen, right next to these like crazy pie looking structures of like center pivot. It's so diverse in terms of what you're looking for, how that can appear. And you often have to look in like multiple wavelengths, spectral bands, as well as over a long period of time to be able to capture as close as we can get to what the true field boundary is. And even then, we might not get the true field boundary because we might not be able to see it. Maybe somebody's like, got a little rope that separates their field from another field. Even getting like what farmers might consider the field boundary might not even be possible. So anyway, compared to doing things like we're used to doing in segmentation in AI, like detecting a person or a car or a bicycle or something like that, which are pretty uniform globally, there's a huge amount of diversity.
Yeah, and I just want to highlight here that we're, fields of the world. You mentioned it before, different geographic locations. This is over the entire world, yeah?
Yes, it is global.
That's a big deal. Can you tell us a little bit about the data sets that you're using to do this? Is there like a mixture of a lot of different things, or are you focused on just one sort of set of satellite images?
Essentially, Fields of the World started as a benchmark data set, which brought together labeled or, annotated field boundaries that were ground truth in some way. So this could come from some countries, like especially in Europe, have published data sets of their farmer reported field boundaries that are really precise and really high quality and you span the entire country. Some others have come from different efforts that might be manually annotated on satellite imagery or manually annotated in the field. So they've come from a variety of different studies. And that's just where the actual boundary label comes from. And then we paired those with Sentinel-2 RGB and near-IR satellite images that overlap those, created, a bunch of little chips that would go into machine learning models for that. And we have those Sentinel-2 images for two different dates that are, we call it window A and window B in the paper, but it's approximately like the planting and harvest timeline. Mainly, we're trying to get that contrast so you can see where the actual boundaries are between fields. And so that together with some different tools and data set splits like the training, validation, test definitions, and et cetera, all those good things that go with a benchmark data set. We package that into the original Fields of the World data set. And then around that, over time, we've built up a lot of different pieces that form a whole ecosystem for field boundary segmentation, including most recently, we just publicly released a global field boundary layer. So this is the first global data set of field boundaries which basically is the predictions of our model trained on the benchmark data set. So that benchmark data set covered about 24 countries. And then we train the model, predicted on the entire world. That gives us the global data set.
Ton of questions here. Firstly, how big are those windows, window A and window B, in terms of a time period? My guess is it's not just like a snapshot this hour of the day. I guess it's broader than that.
Yeah, usually it's a couple of months. We got those windows that we use to create the data set in the benchmark from USDA crop calendars that they produce for everywhere in the world. So we get these several month windows and pick the highest quality image within those windows.
Okay, yeah. So this is also in terms of cloud cover, I guess.
Yeah, so we look for like the lowest cloud cover, lowest no data, so trying to do all those filters to get the best looking image. And sometimes you don't even find an image in that window. So for some places, you have to expand, like a half a month at a time until the algorithm finds a good fit.
I think you said you had 24, 25 countries where you had these existing boundary data sets. How well did that translate over to vastly different geographic areas? So you're talking about Europe, for example, with these great polygons and awesome precise data. Did that translate nicely over to the Philippines?
Sometimes yes, sometimes no. So what we did in the global data release was to pair that global data set with a global confidence layer. So we basically trained another small, interpretable model that would take all of the kind of prediction metadata from our model trained on those 24 countries about, how confident it was in terms of like probability scores from the model, what other data sets said in comparison, like land cover data sets, a few different covariates that we use to basically train this model to predict how likely it is that the global boundary layer's boundaries are correct, are true positives. So we have a confidence layer that you can tune if you go to the Global Data Explorer. You can tune that confidence from 0 to 100 and be able to filter out fields that we're less confident are actual true predictions of field boundaries. And so, it's really not like a easy mapping. It's not like you can say like, oh, in all small fields, it's bad, or like in everywhere it wasn't trained on is bad. It does well in a lot of places, does not do well in some other places, but we do see that our confidence layer does a pretty good job knowing when it's wrong.
Where can people go to do that? What is the URL? What's the address?
Yeah, so the easiest place to go as a starting point to find any of this is at fieldsofthe.world. And I will send you the link to the actual inference app. But if you go to fieldsofthe.world, then you will see where to view that global explorer. So like if you just scroll down on fieldsofthe.world, you can click Open Explorer app, and then you can see the global data set.
Can I download data from that?
You can. So we tiled up the world into a download grid. So that makes it super fast to download just from your browser. If you toggle on the show download grid in that Explorer, you can just click on any grid and download all of the field boundaries in that area.
Fantastic resource. Will you be doing this on a regular basis? Can people see this as a foundational data set?
Yes. So we do plan to have continual releases of this data. So right now we have layers for 2024 and 2025. We'll be planning to do it for 2026 as well, but we're also continuing to make improvements on this. So you'll also see in the Global Explorer that if you zoom in, there are options to give feedback. So you can rate the fields in the viewing area, and you can give more detailed feedback on what you saw working well, what you saw not working well. And we're using all of that feedback to make improvements behind the scenes. So I hope sometime this year we'll also have a big update to the benchmark data set itself, but also this global layer.
That is interesting. How clean, useful is that feedback going to be for you? Because I know with other sort of crowdsourcing models, it's difficult, right? You want the best possible feedback.
Yeah.
Do you know what I mean? Like how Are you going to train some people how to do this? What does a good field look like?
Yeah, no, that's a very good point. Like a lot of people, what everybody does in this viewer too is they like zoom into a place they know really well, like their house, and then they're like, doesn't work here or something like that. So, it can be a little specific in terms of the feedback people give. But, that's okay. We want to know that too. We tried to kind of get somewhere in between making people have enough skin in the game to submit useful feedback. Like we didn't want to make it so easy that you could just like click on a bunch of stuff and send spam a bunch of garbage. But we also, didn't want it to be too lengthy or too difficult to give feedback so that like you start doing it and then you're like, never mind. Or, you're not able to give very much feedback. Maybe you stop after one submission. So we don't really have any kind of blocks on there, but we do have, for example, one of the things we do is if you select poor, acceptable, or good and submit that, you have to kind of select why. So you have to say there's checkboxes for, fields are missing, fields are over-merged, things like that. So you have to explain. I thought of this in some apps, like, for Uber or apps like this where you have to give feedback. Like if you give a rating, if you give whatever your rating is, it automatically prompts you to explain why. And I think that helps people have a bit more accountability for what they're submitting. So far, we haven't really seen people just spamming. We've seen pretty useful feedback.
This is interesting. For me, I would have thought that you were going to say, great, so zoom into a polygon and correct the polygon for us. So that would be the most useful kind of feedback, or just adjust the corners.
Yeah, and that is what we're working on and trying to figure out what is a way. Like a lot of people want that in the public, but including on our team. I've been the one kind of blocking it for a while to say like, hold on, my people, we have to make sure that this doesn't lead to, again, like it's really not clear what a field is. Like it's not just like anyone can do it. And so what we are doing is collecting interest from people about who wants to contribute. I think eventually we will have some sort of correction tool, but we need to put a lot of thought into that and how we can make sure that we're not just like essentially creating slop if we're using that feedback to train our models. We want these models to predict something that is real and meaningful to agricultural decision makers.
Sounds like you're going to curate the feedback that you're getting, and the people giving the feedback.
Exactly. Yeah. So we are looking at the interest that people are sharing through the feedback forms to identify who is interested and has the skills or maybe coincident responsibilities in their own jobs or something like that. Really looking for people who want to be partners to contributing to this and helping to shape the data set in the future rather than just kind of crowdsource blindly.
I have a sneaking suspicion that some of this stack might be based on cloud native stuff. Is that correct?
Yes, everything is cloud native. Yeah, we've been from the beginning, that was part of the whole idea of the innovation bridge through Tailored Geospatial was that as we academics were working on this data set and these different tools, we would have various engineers that Tailored Geospatial calls tech fellows who are working alongside us to make sure that we're using best practices, using all of the best cloud native tools available, using the right standards, making sure things have appropriate licenses to not restrict its use. And I think that has led to just a dramatically more usable output from this project.
Is that usable from the end user's perspective or also usable from the people that are creating this? Because I imagine there's less infrastructure involved when you're setting this up if it's cloud native from the start.
Yeah, I think it's usable from both. There are things like using GeoParquet or different standards. We worked with various partners to make sure that we were making cloud native GeoTIFF mosaics or making the data downloads or the underlying layers in a form that would be easily accessible by various users. So a lot of work behind the scenes went into not just using those tools and identifying the right ones, but I think like you're saying, some things had to be developed along the way or extended along the way too.
So Fields of the World, it sounds amazing. How does it sit with other stuff that's out there? So Google creates some big data sets as well for this kind of things. We've got national cadastral records. We've got commercial vendors out there. I have a feeling I know the answer, but tell me please what gap you're filling.
Yeah, so the biggest difference between what we have done and what other efforts are doing is that it's open source through and through, right? So everything that we're doing is in the open. Anyone can contribute. You can see everything. Everything is free to use. You can just go, we're not selling these field boundaries. It's really meant to be like a shared public good technology that everyone can benefit from, but also can share the responsibility to contribute to. So if people want to make improvements to it, they can invest in it as well. There are various companies that have different products that maybe sell field boundaries or some downstream product on top of field boundaries. Maybe they're more tailored to particular regions or use cases. I don't necessarily think that this open layer competes with that, because I think most companies are not just trying to sell the boundaries. They're trying to sell insights on top of that or different tools. So I think it really is a rising tide to lift all these different boats.
Have you seen any of these companies sort of pick that up and ingest this into what they're already doing?
I have heard of this. I know, like, for example, we have a great relationship with the team at Google, Anthro-Krishi, that did the agricultural land understanding tool. And I know that they are using our resources, like our benchmark data set, and to help advance their tools, even though theirs is not like a public model or a public global data set. They have an API structure that you can use within like the Google Maps API, I think. But in that case, like our benchmark data set allows them to work on making improvements to their product without having to necessarily put what they're doing out in the open.
But like you say, a rising tide.
Yeah. And like I said, like we're not trying to really arbitrate who can use it, who cannot. That's why we've made everything CC BY. We have a CC BY version of the data set. So there are a few of the data sets in the Fields of the World benchmark that, since we inherit their licenses from the original labeled data sets, some of them don't allow for like fully unrestricted use. They have, a share alike or some other license. So there's a version of the data set that is more restrictive, and there's a version that is completely open. And, we have results in our GitHub repo as well that show the differences in performance if you use each one. And there's really not a huge difference. So, and the global data set is made with the CC BY licensed model as well.
This might be an incredibly naive question, but is this a model that I could take and fine tune for my own geographic area?
Yeah, for sure. So the model weights are public, the code is public. So you have a lot of different options. For one, you can download the model weights and then use that as the starting point to fine tune the model for your region. You could also take the benchmark data set, take your own data and combine them and retrain the model from scratch. It's not like it's a, ginormous LLM scale model. It's very feasible to do. And there's, a lot of instructions online in our GitHub repo for doing all of that. You can also tune the inputs to the model using that same inference app. So in the global inference app that we've been talking about, there's another tab at the top that says custom. And you can use that to kind of use the user interface without writing any code to pick the model weights, pick the different parameters, which input dates you want to use. You can pick the images that go in rather than using our pre-populated ones, and tailor it that way too.
Would there be any benefit for the overall data set if people did that and contributed that back to the global data set?
Yeah, I think what we found with different users is that some people will use what we've done as a starting point and see like, okay, what changes can I make? Not just adding local data, but also changing the loss function or changing the weights of the countries or doing various things that will improve performance in a particular area, but may also improve the performance overall. So that's a benefit of having this benchmark data set along with it. We can have a shared point of comparison for when people are making these different advancements. We can see how does that improve performance on a common set of tasks.
How does your model compare to something like Clay? Well, Clay is the one, I'm sure there's other sort of foundational models out there, but Clay is the one I know best. And it sounds like you're tuned for a very specific purpose, where Clay is more, find anything that looks like this thing.
Yeah. So Fields of the World and the models trained on it, this is like a fully supervised task and model. So Fields of the World is like a downstream task for models like Clay. Like you wouldn't use the features extracted from it in like a general purpose way, like something like Clay is for. So for geospatial foundation models, it's a very different setup where they're trained in a self-supervised way without any labeled data. So agnostic of a particular task. They're trained on lots of different data sources or locations to do kind of a generic proxy task. And then that model is then used for adapting to downstream tasks like Fields of the World.
Okay, right. So this is my uneducated understanding of it. It sounds like that could be an input into something like Fields of the World.
Yes, and we actually tried that. So we have a paper that we just presented at CVPR, the Computer Vision and Pattern Recognition Conference, just the other day on Friday. We had a presentation there on our new paper called PRU, which is like a really tortured recipe for a practical recipe for field boundary segmentation at scale. So it's called PRU as a call out to Great British Baking Show, because when we started this paper, we called it the Great Model Bake Off. And there we said, okay, in the first paper, when we published the benchmark data set, we were really focused on advancing the data set and didn't really care about which models we were using. We tested a few, but we were like, whatever, the biggest gains are going to come from this new data, not a new architecture. And then in this model bake-off paper, we said, okay, let's test all the models. So we did a huge sweep of tons of different model architectures, like hundreds of different models, different, loss functions, different parameters, all kinds of different ways, and benchmark them on this data set, including maybe like 10 or so geospatial foundation models, including Clay. And what we found was that those models still are not really comparing to just a really well-designed unit for segmentation on this task. Again, those models are designed for like very generic utility. What we found was that at least for this task, in order to get performance that even really got close to the fully supervised models that we found excelled the UNet recipe that we kind of ended on, you would just need to do so much exploration of different model decoders to add on to those unsupervised or pre-trained model encoders. I think Clay actually ended up doing the best. None of them did great, but out of all of them, Clay did pretty well. We think because it has the smallest patch size. So a lot of the models really just had very kind of blurry representations, I can say, of the inputs, and that led to like not very crisp segmentations. And the field boundaries can be so narrow.
I guess in some ways it's not really surprising that was the findings, but it's really nice to have some data behind that, I guess.
Yeah, it's not super surprising, but it's disappointing because, that's really the goal of these geospatial foundation models, is that we should be able to use them to kind of jumpstart progress on many different tasks. But, for now, maybe given the size of the data that we have, there's like 70,000 samples in Fields of the World. So it's not like it's a low data task. The kind of custom, fully supervised models work best. Another big consideration is just cost. So we have a metric in the results for that paper that we call throughput, which is the kilometer squared per second that can get processed through each of these models. And that is basically a direct translation to cost when you're predicting a global map. So, how many kilometers squared per second can you process on the globe when you're making predictions with each of these models? And foundation models, for the most part, are like an order of magnitude larger in terms of lower throughput than the custom UNet models that we actually use in practice. So that's, again, like orders of magnitude more cost to predict a global map. So even if you got some small performance gains, it wouldn't be worth the cost.
Yeah. Yeah. There's also a really interesting way of looking at it. Is there any one sort of data set I could show up with to give you tomorrow? Say, here, have this data set here that would make like a massive difference to the accuracy of what you're already doing? Is there like an input you're missing? Is it just extra training?
Yeah, like if you took our confidence layer and you sampled like all of the lowest confidence areas and had experts annotate, the boundaries there and add that to the model, that would definitely improve. We're going to do that. So, we'll be working on that this summer anyway. That's a big update that we'll be making to the model. But, right now what we've seen is like the shortest path to improvements is adding more data where the model does poorly.
Right, so more data in terms of these labels, these annotations, or more data in terms of, what about higher resolution satellite data?
For sure. That would also help. Not everywhere, but in a lot of places where really we're getting like past the limits of Sentinel-2's 10 meter per pixel resolution, a lot of smallholder agricultural areas, you really can't see the boundary, or they're really stair-stepped artifacts on the field boundaries from that pixel resolution. We're in conversations with Planet and other providers about how to incorporate higher resolution data into this data set and into the ecosystem in a way that, is as open source and accessible as possible. Obviously, when you're getting in with like paid data providers, that gets a lot more complicated. So we want to do everything we can with public data, but we know that higher res data would undoubtedly be helpful.
Sounds like you might be a big supporter of Common Space.
Oh, yes. And actually, Rhiannon Price of Common Space also is part-time with Taylor Geospatial. So she's involved in this as well. Yeah, she's on the Fields of the World team too.
When you are thinking about how can we get higher resolution data and how can we integrate it, that's one thing. Are you also thinking that can we do this again next year and the year after that and the year after that? Or could you make a huge increase in accuracy, precision by having that input just once?
That's a good point. I think we haven't looked into much like how sensitive the model is to temporal differences, as in, like, do we have some drift that's happening as we continue to see, for example, if when Sentinel-2 ceases to exist and, another sensor is going to be used, of course, these kinds of things will come up. I think so far we haven't really seen any stark differences year to year. I think, having to repeat this just may depend on people's resources per year. Like we may need to do one round this year, see how far we can get. And then there's always like, the edge of the error to uncover. We're constantly trying to take the bit of the error that's left and improve on that. So I'm sure it's going to be iterative. I don't think we'll be done this year forever.
When I think about foundational data sets, I think about something that's repeatable, something that's open, understandable, and something not just repeatable, it's going to be here next year as well, and the year after that, and the year after that. And a lot of times that comes down to funding. So who pays for this? How do we know it's going to be there next year?
Yeah, so Taylor Geospatial has been paying for this, essentially. They have been paying for the research behind it and paying for the compute to provide it, et cetera. But I think as we create this pretty large now community in open source around it, our hope is that we start to see people taking on bits of that responsibility and that it kind of stays afloat in the future through this community of users and different companies that are using it themselves and then giving back through support, right? So a company may be using it for a commercial use that goes in a product, and that doesn't necessarily go into the open. But if this is a useful resource, they contribute back to it. I think that's what we're seeing happen already.
How do you end up not in a situation like QGIS, for example? So QGIS is used everywhere by everyone, and the products that are created with it are paid products. People are buying these services and products from the people that are using it. And now they have okay sustainable funding model, but I don't think it's amazing. I don't think it's like fantastic. I don't think they're sort of swimming in cash. How do you avoid that?
Yeah. Are you saying, like, how do we make sure this doesn't become, like, my hobby for eternity? I'm here when I'm 80 years old updating this repo myself.
Pulling the handle yourself.
Like, honestly, if that's what has to happen, it probably will. But I think in some ways, like, the fact that we have a lot of help from our agent friends, our LLMs, definitely helps us to sustain things with less of our own time. So I think that honestly just by far helps with sustainability. I think it also lowers the bar for a lot of people to participate in open source projects. So even though we still, have a review system, it's not just going to be slop on slop. It still helps to allow more people to make changes, especially that are like low-hanging fruit, bite-sized stuff in a community project. In terms of like the long-term sponsorship model, I don't know. Well, I know that there are several people in Tailored Geospatial that are much smarter and more practiced in this kind of stuff than me, like Chris Holmes, for example, who did GeoServer and like a billion other things in the open source community, is part of the team. So I trust in him. We all just do what we do best on this team.
Yeah, cool. Yeah, it's important to have specialists. When I think about infrastructure, I also think about that side of as well. Like, it would be nice if it was going to be here tomorrow, the next year, and then we can build on top of it.
Totally. And we have so many organizations invested in its success. NASA Harvest is a partner as well. So, these different organizations will help keep it afloat. Microsoft AI for Good is a partner as well. I think that by having all of these different partners involved, we'll keep it going somehow in the community.
Yeah, I really hope so. What is this going to look like in 5 years' time? What are going to be the big improvements? Are you going to be millimeter accuracy over the entire world? What is it going to be?
Oh, yeah, for sure. In 5 years, performance will be way better. When you zoom in on your backyard, when you get to the portal, you'll be a lot happier, I hope. Yeah, so I hope that in the next several years, we'll improve a lot of these like major limitations in the data set right now, especially for like smallholder farmers, which have such a huge share of the global agricultural production. I think you'll also see a lot more sensors. I think this will move from being kind of an ad hoc case of this data set and predicting one kind of field boundary with one kind of data, move to a much more flexible ecosystem that also leads to more flexible models that can predict more about agricultural fields, not just more accurately.
Yeah. Also think that if you can nail that human in the loop piece of this as well, those experts around the planet that are invested in this, helping out,
exactly.
That would be incredible.
Yeah, for sure. There's a lot of expertise and a lot of people who want to solve this problem.
Well, I want to say thank you very much for the work that you do. Thank you very much for taking the time to talk with me today. I really appreciate it.
Thank you.
I'll be sure to link up all of the things that you've said in the show notes so people can find this resource and play around with it themselves.
Perfect. Yeah, share your feedback with us.
You surely will. Thanks again, Hannah. Really appreciate it.
Thank you.